All right. So we're going to talk about working with volumes at this point in time, and we'll talk about kind of what they are, and then the process of provisioning them. And here's all the stuff we're going to talk about. What is a volume? Understanding performance policies, and we've already talked a little bit about that in conjunction with data reduction and deduplication. Access control for volumes. We'll talk about production templates a little bit, but really more around volume collections, which is how we control snapshotting, and pinning, which we've referred to a little bit earlier today, and then go through the process of actually creating a volume. So really that's, I think what you learn the most is just going through the wizard of actually creating it and then connecting it up to your server, which you'll do in the labs. So just kind of go through the concept here of what a volume is. There is technically a difference between a volume and a LUN. And sometimes we use those terms interchangeably, but on a Nimble storage array, it really is a volume. It's not a LUN. There is no direct physical mapping of underlying storage devices to what's being presented to the to the hosts. And so you don't say, these drives, make up this particular, LUN, and then offer that up, or this set, this subset. It's all the drives in a Nimble storage array make up the triple plus parity storage pool. And that's all the RAID sets, right? I mean, if every bank of drives is its own RAID set, which would be an entire shelf in an adaptive flash system, or, the two banks that are in a shelf of an all-flash system. And then even if you add additional expansion shelves, all that together makes up one pool. And that pool then is offered up in an abstracted way to then be divided up into volumes. So if we take just a piece of that pool and we allocate it and offer it for access by hosts, that's what we would call a volume. So when we, by default, all volumes on a Nimble storage array are thin provisioned. You can create a volume that is 100 terabytes, let's say, and which you can create a volume that large. And 100 terabyte volume, once that's provisioned, you're not utilizing any space at all. And in fact, the full capacity of the pool is available, and the free capacity is available for any other volume as well at that point in time, until you actually start writing data. And then once the data is written to the, into the pool, so that's after data reduction and after encryption and all those things, then it starts actually utilizing space. So do people over provision, right? Since you can, I mean, I could, if I had a pool, I could create, let's say that my overall pool is only, 33 terabytes, right? It's a 42 terabyte array. It's 33 terabytes of usable space. Could I provision 300 terabytes of volumes? Absolutely, you could, if you didn't write anything into them, right? And so, yes, you have the ability of over provisioning. It does manage reservations. The system itself manages and keeps track of reservations. As you provision more, it dynamically changes what those reservations are, also based upon amount of data that's written into the system. But ultimately, as far as consumption of the overall pool and consumption of the volume itself, that capacity is only consumed when you actually write data, and by the data that is ultimately written after it's reduced. So there is a certain amount of space, though, that is considered a reserve. A reservation reserves the guaranteed minimum amount of physical space for the pool or for the volume. And that will dynamically change. There are some commands you can do to mess with that stuff. There used to be a place in the UI when you would provision volumes where you could change some of those settings. And that was actually taken out of the UI because, first of all, 99% of our customers didn't use it. And then of that 1% that did, most of them ended up breaking things more than helping things when they played around with those reservations. So it's not something you even manage. It's dynamically managed by the system itself, and the reservation percentages and amounts will fluctuate based upon what your utilization in the system is, as well as how many volumes are actually being provisioned. So there is a quota that's going to be set up, and this is how, right, it's going to set up thresholds. These are your low and high water marks. There's a quota for the set amount of the volume that can be consumed before the alert is set. And by default, I think it's about 80%. And that also could be modified, and it was part of the original volume setup, and that has been removed because, again, there's not a whole lot of reason to mess with that. If there is particular the volumes that have a lot of fluctuation in how much space they take up, and you want to watch that a little more closely, you can actually then change that quota. You could drop that quota if you wanted to. And that's totally up to you. But by default, that quota is all just going to kind of be built in there. Like I said, 80% is usually where it starts giving notifications. Let's see here. There's also the concept of snapshots, right? So there's the volume itself and the capacity that it takes up from the data that's written, but there's also this data that's associated with snapshots and the retention of those snapshots. It also has a reserve capacity and a quota capacity. That capacity is outside of the volume itself. That's different with some other storage platforms where you actually provision a volume and you have to take into account how much space you need for snapshots and what the reserve and the quota is going to be. And on a Nimble, you don't do that. You provision the volume based upon what the application needs. Snapshot data is held outside the volume. It has a reserve and quota with it as well. And then you can see what the overall utilization is when you go in and you look at the array. And the array is monitoring all that stuff for you. There has been a technological change on the Nimble storage platform as far as accessing and mapping paths to volumes from hosts over the last, when did this come out? A little over a year ago. We switched the technology from volume scoped targets to group scoped targets, VST to GST. This is transparent. This really isn't something you have to manage, but it is kind of a nice to know sort of an idea. And the concept, and this was in the 5.1 code that this particular piece came out, so that at 5.1 and later, by default, you're using group scope targets. Previously, you're using volumes. And if you upgraded, if you were running the older code, then you're going to continue to, it doesn't change anything on the volumes that you previously had. But the concept here is that with a VST, each volume is a standalone iSCSI target with unique IQN. And so what does that mean? It means a ton of IQNs. It means a ton of iSCSI targets in your environment if you have a ton of volumes. If you don't have a ton of volumes, then it's not. And when I move to group scope target, there's a single iSCSI target across the whole group. So even if you had multiple arrays, right, you could have a single target for iSCSI. And there's a few different reasons why that's helpful. vvols being one of them, since we already talked about that particular piece. If you're familiar with vvols, right, you're mapping the volumes on the storage directly to your VM guest. And so each virtual drive, if you will, on a vvols VM is going to be a literal volume on the Nimble storage array. So the question then becomes, well, how many volumes does that equal? If I deployed vvols into an environment with 100 VMs, let's say, now my volumes went from the, 6 data stores that I was using before, each one of those being a volume. Now I've got, at least 3 disks for each one of my VMs. So now I've got 300 vvols, more like 400 vvols. So now I've got 400 volumes on my Nimble storage array. And you can see how that could grow very, very quickly. There are volume limitations, especially on the adaptive flash systems. On the adaptive flash systems, you've got a 1,000 volume limit that you can hit per group. And so in a large vVols deployment, that could be problematic. So that's one of the things that group scope target addresses, is it allows you, I mean, if you've got one target per, then you don't have to worry about hitting your maxes. There's also, in VMware environments, again, this is around vVols, there's a limit to the number of iSCSI targets that you can actually deploy in a single VMware environment. And so, it gets around that particular piece, right? If we can do this now by system rather than for every single volume, it helps. The other piece where this comes into play is if you are going to do synchronous replication, meaning I've got two arrays, and I want to basically do HA storage, and I want to be able to do automatic failover from one array to the other one if a data center goes down or the storage were to fail. You can now do this because they are grouped together, utilizing, and you are synchronously replicating the volumes between the two. And because they're in the same group, and there's a single group target for the entire group, when you fail the volume over, there's no disruption, right, to the overlying hosts. Hopefully that makes sense. If we get some time, the last section that we have queued for today is to talk about pure persistence, which is synchronous replication on Nimble. I don't know if we're going to have time to get into that or not, but if so, then we'll talk about this just a little bit more. But again, you don't really need to understand how it works per se in order to make it work, just that is the way that the technology is led to. And if you've been running Nimble in your environment for a long time, you may very likely have a mix of group scope target and then volume scope target volumes in your environment. If you need to convert a volume scope target, you can contact support and they can help you go through the process of making that conversion. And I already talked through all of this stuff, so we will continue on. We already talked a little bit about performance policies, but let's just review it and move in here. There are, by default, I think 16 different performance policies that are within the Nimble operating system. And what's the performance policy? This is an attribute that you assign to a new volume when you create it. And basically that attribute dictates what application is going to be running in it, what block size is the standard block size it should expect for reads and writes, and it optimizes appropriately. By the way, we all know that all applications write in different block sizes and it changes over time. So it doesn't mean that it will only read and write in that block size. It means it optimizes for that block size. So it'll dictate the type of application, the block size, data reduction settings, so compression and dedupe settings, and then you'll notice that the last setting over here in this calling for each one of these performance policies is what is it going to do when you get full. If a volume were to actually fill all the way up, would it go offline or would it go to non-writable, which is this one right here. And you can see all the settings for these different ones. There's a default setting, which is kind of blanket for everything. And right, the application is other, because there's not a specific application. Block size is 4K, compression's enabled, dedupe is disabled. And it's set to go offline if you actually fill the volume up. And each one kind of has their own settings, and you can see what the application category, all of these have the same application category, but they have some different other settings based upon what version of Exchange or whether it's an Exchange log volume, right? You can see 4K, 8K, 32K, 16K, right? Because these different workloads generally write in these different block sizes, and so we try to optimize for those. Yet we can still dedupe against each other if they have the same block size because they're the same category. In this case, they don't, right? These are all different block sizes. We can see the two Hyper-V ones in here, even though they're different versions. One's for VDI, there's one for VM storage as well. They have the same block sizes though. They're using default deduplication, but they've got, right, it's enabled for the VDI, but it's disabled for the VMs by default. And then we can see they both go unwritable rather than offline, so they stay online. So you can also create your own performance policy, and actually I recommend doing this. If there's one that doesn't seem to fit well, or if you have custom applications in your environment and you want to optimize for your access to those. So now remember, these performance policies are used to dictate what it dedupes against. So when you apply your settings in a custom performance policy, you want to keep that piece in mind. If you know there's other types of applications you want to try to dedupe against, for instance, this particular application runs all on Windows servers, as well as another application, you might want to make sure they have the same application category and block size so they'll dedupe against each other, theoretically, right? Unless you know there's no shared information, maybe you need something different. But again, this is how you do it. You name it. So you give it a name. In fact, I've seen some people do this for when they run their file servers virtually in their virtual environments. They actually create a separate performance policy just for file servers. It allows them to track their file servers more closely, and it also allows them to apply some different settings to them. So they did VMware file servers is what they named it. Application category that they put on there was actually file servers. Though after talking to them, we changed that because they were running it in VMFS data stores. So VMFS is actually what was accessing the array, right? Not the Windows file server that they were running. So they changed it back to virtual server, but then they changed their block size to 8K, I think. They enabled compression. Actually, in their case, they turned compression off because of what they were storing on their stuff, and they turned dedupe off because they were storing stuff that wouldn't dedupe in these file servers. But again, you have the ability to set all of that stuff, change your reduction rates, and then what do you want to do when it gets full? Any questions on creating a performance policy or the ones that are in there? Nope. Okay. So initiator groups are kind of the next piece. When you're creating a volume, you have to be able to dictate what's going to have access to that volume. And this is done through I groups or initiator groups. And the concept is the same whether you're doing Fiber Channel or iSCSI, though the settings are going to be a little bit different. With iSCSI, you are applying IQNs and IP addresses to have access to the volumes. And with Fiber Channel, you're applying worldwide names in to it and LUN numbers. So let's see here. When you are setting this up, and it does make a note here, right? What you're gonna do is you create this is initiator group. You could have a group of one, meaning a single host is its own group, but the concept is that there's multiple hosts that need to be able to access a particular share. Because it's shared storage, or if you're doing some kind of clustering, maybe that would be beneficial as well. And the idea here is that you would take then the IP addresses, the names, the IQNs, or the worldwide names for those different hosts. You would add them all to one group, and then you would apply that group to your volumes. For instance, all of your ESX clusters or all your ESX servers in cluster 1 in your primary data center in Seattle, let's say, they could all be part of the same I group. And then when you create a new data store for those for that environment, you would simply apply that I group and all of the hosts would then have access. Hopefully that makes sense. If you are doing multi-access clustering, high availability clustering and stuff, in an iSCSI environment, you need to make sure you check the box to allow multiple initiator access so that multiple hosts can read and write out of the same volume at the same time. Hopefully that makes sense. If that's not for MPIO, right? This is specifically for like high availability and clustering type of solutions. Let's see here. I already talked through this stuff. The parameters. Okay, so what's the actual settings that you have to set up for initiator group? There's a name. This is just a metadata tag. Like this is a label. I suggest using something that is descriptive of what the group of initiators actually are. So if it's, ESX cluster 1, then, you name the group ESX cluster 1, and then you would add in when you're doing iSCSI or the fiber channel setup, you can put an alias in here. It's completely optional, but basically it's just a name of what that host is, and then you put your WWPN in there. And the nice part about this is WWPNs are shared using the switching fabric itself, so you can actually start typing the name. It will search and give you a list of all the ones that you can pick that are connected to that fabric. So in that way, fiber channel is very, very easy and nice, and then you continue to add those down. You don't even have to, though, put an alias in if you don't want to. For the iSCSI piece, again, give it a logical name for the group of initiators. lock down your subnets. I do highly recommend you do this. You have the ability to allow access to, to a volume through the initiator group from any subnet or any set of IP addresses that's connected to the array. So if you have multiple data networks, and you can use this to then segment it out, right? You can say, well, this data subnet has access to these volumes and this one doesn't. So you could do multi-tenancy sort of things or micro-segmentation if you needed to do that. But one of the key things here is one of the subnets that's connected to every Nimble storage array is the management subnet. iSCSI is a routable protocol, right? It runs on layer 3. You could theoretically, or I could theoretically, hack into your network and set up an iSCSI connection into your iSCSI network if you had a gateway on your iSCSI network, right? And your Nimble array was allowing access from all subnets. And even if you didn't, right, let's say that you didn't have a gateway, which would be best practice on your iSCSI network so that it's closed off because you don't need gateways on an iSCSI network. There's no reason to route iSCSI traffic. So you've got that locked down. If you've got this initiator set up so that it's accepting iSCSI connections over the management network, then now I can get in there that way. So again, just best practice would be lock this down so only your data networks have access on your iGroups. And then the secondary piece would be take routing out of your data networks if you can help it. There's no reason to have a gateway on an iSCSI network, right? Because it should be basically layer 2 between your hosts and your storage. You'll add your name, and this is a friendly name that allows you to identify whatever that server is or whatever that host is, the IQN from that. Just as a best practice, because some people are kind of crazy, don't try to type IQNs in. Log into your host, copy it out of the network configuration and paste it in. That's a really long hexadecimal address. There's too much chance of fat fingering that. And then you can apply an IP address. Very common, people just put a wildcard in for the IP address, allows them to change things. You're already locked down. The IQN is unique already for that given host. But if you want to lock it down even more specifically, you can put in the specific IP address that host is utilizing for that IQN as well. I already talked about this stuff. The configuring snapshots or the configuring subnets, this is the piece that I was looking at. And so when you use configured subnets or use selected subnets, what I would suggest is go to the selected subnets option, and this is where you choose it, right? Leave management out and just add your data subnets. The other piece, okay, so there is a limit to 255. Oh, when you apply an initiator group, you can apply it on all these different levels to the volume. So just to the volume and the snapshots for the volume, or just the snapshots only. And for instance, if you're utilizing a backup application like Commvault or Veeam that does snapshot integration, you can actually make it so the Commvault server doesn't have access to the volumes at all, only the snapshots. And that would be how you would utilize that. You can create protection templates, which are just templates that allow you to create volume collections. And volume collections are how you configure snapshotting. I'm not going to spend a bunch of time on the templates themselves. They're pretty straightforward, but we will talk about volume collections. The concept here, sometimes the naming can be a little bit confusing to people, but because they don't really think of, well, how is it? Is it a collection of volumes? Like, what is that really for? A volume collection is a configuration you can apply to one or more volumes that applies the snapshot configuration. So the snapshot schedule or schedules and the retention associated with that and the replication settings for those snapshots. So that's what you do with a volume collection. Commonly, the best practice would be that you would have a small number of volume collections associated with specific SLAs in your environment, meaning You would have your gold level volume collection, which would be for all of your gold level applications or your tier 1 applications. And maybe you'd have one for tier 1 databases and one for tier 1 application and file servers. And I'll explain why you might split those out here in a minute. And then you would have a tier 2 for tier 2 databases, tier 2 web servers and file servers, and then maybe a tier 3 one. And in each one of those volume collections, right, you would have different settings. How often are you going to take a snapshot? How long are you going to keep them for? Where are they going to be replicated to? What's the retention going to be on the replica? All of that stuff. And so this is what it looks like when you create the volume collection. Log into the UI, you go into a new one. This is the wizard. You'll give it a name. So this could be your tier 1 databases would be the name of this one perhaps. You would choose what your replication partner could be. That replication partner could be another Nimble storage array. It could also be an HPE Cloud Volumes target. So you can replicate directly to HPE's cloud storage platform. Just FYI, no ingress or egress fees in order to do that. You just pay for however many terabytes of capacity you need to hold this stuff. And it does give you a very easy way without deploying additional infrastructure to have a copy of your data offsite. So you choose your replication partner, you choose a synchronization service. Now, snapshot synchronization is about having application versus crash consistent snapshots. Application consistent snapshots quiesce the application when they take the snapshot. So in case there's any transactions happening when you take a snapshot, that you can you can make sure that you don't lose those transactions or that data isn't corrupted. You don't take a snapshot in the middle of a transaction, if you will. Now, you only need to utilize a synchronization service if you have a transactional application. So, for instance, if I'm running a file server or a web server, there's no transactional application associated with those things. Transactional applications happen when there is like a database. So a SQL database or an Oracle database. Exchange has a database. If you're running a SharePoint site, there's a backend database in that. So you need to know what it is that you're trying to protect and what's going to be in that volume. And this also drives that question that the answer to the question of, well, how do I decide how I split up my VMs or my applications into my volumes on my Nimble? One of the primary drivers should be, how do you want to protect those applications? And that's going to be then dictated by this. So for instance, if I'm running a particular volume and I know there's going to be SQL databases running in that volume, say it's mapped to a data store and that's going to be running some SQL databases or a physical SQL cluster, right? I would go in here and I would choose my Windows or my VMware synchronization service. Let's see, yeah, here, it'll even show me here. So here's your options. It's none. There's VSS for your Windows platforms, and there's vCenter, and it utilizes your VMware tools that need to be then installed on your guest in order to synchronize with those. And so you choose one of those. When it takes the snapshot, it will then quiesce that VM. And keep in mind, this snapshot is at a volume level. So when it takes a snapshot, it's going to snapshot everything in the volume. That's everything in the data store, which would be all the VMs in the data store. And so if it's set to use a synchronization service, it's going to try to quiesce every VM in the data store. So now we're thinking about, oh, well, so I'm going to choose what's going to be in a data store based upon how I want to protect it. Meaning, if I mix my databases and my web servers into the same data store, and I want to quiesce them all, it's going to be trying to quiesce my web servers, which is a waste of resources, and will elongate the time it takes for the snapshot to run. So again, just something strategically to think about how you split up your data into your volumes. So you choose your synchronization type based upon whatever it is you want to do there. You can do synchronization also. I should point this out. You can do snapshot synchronization on Linux platform as well, but you have to install a toolkit on the Linux guest itself, and it actually the snapshot synchronization is kicked off from the tools side and then tells the array to take the snapshot. So it runs in reverse rather than it taking the snapshot and then telling the operating system and the guest to quiesce. So once that's set up, then you go in and you set up a schedule. And the best practice here is going to be make sure that you name your schedules in a way that reflects what the schedule is. And so you might type in, you might label it daily retain 7, right? So a daily snapshot keeps 7 of them. And you can choose what days of the week you want to choose, what your retention period is, when the snapshot is taken, what the interval is of how often it's taken, and then for the replication information, right? Where do you replicate to? How many replicas are you going to keep? Do you keep every snapshot, every other snapshot, every fifth snapshot, and then how many of those are you going to keep at that? And you can set up multiple schedules. So you could take a snapshot, every 15 minutes and keep that for, 24 hours. And then once every hour and keep it for 3 days, and then once every day and keep it for 30, right? And that would be 3 different schedules then that you would set up. And so the concept would be, similar to what is your target? What is your strategy around your RTOs and your RPOs for your data protection? And again, this then drives the idea that you want to have data that you want like protected in the same volumes. And if you have like a non-critical file server, you might not have that in the same volume with the database for your ERP system, because you want 15-minute snapshots quiesced on that one, and the file server once a week, right? And it doesn't need to be application synchronized, right, for that particular system. So it doesn't make it would be problematic, right, to have those in the same volume and to utilize snapshots that way. Any questions about configuring the snapshot so far? Does that all make sense? Yeah, am I putting everybody to sleep?
Hey, the storage that's used for these snapshots, that counts towards the entire store, right?
It counts in the entire pool.
Right.
The snapshots are not part of the allocated space for a volume. Yeah.
Okay, so when you're looking at like the total available, say it's 30 terabytes, it's going to start taking away from that 30 terabytes, though.
Yes, it will.
Yeah. Okay. All right.
Yeah, it won't take up, like, for instance, if we're talking about like data stores in a VMware environment, and you've allocated a 30 terabyte data store, and you've got a bunch of VMs in there. When you start taking snapshots, it will not take up space in the data store. It will take up space in the storage pool on the array.
Yeah. It's just a matter of doing math, right? You got to take a couple and see what you're looking at. So.
Yeah.
Cool. Thanks.
So we've already kind of talked about creating the volume, and you got to set up the initiator group so your host can access it. You want to set up data protection. I do recommend every volume. There's no reason not to have some snapshotting configured. And here we'll get into the kind of how snapshotting storage pans out here in some subsequent slides. But I just highly recommend that even if it's just you take one snapshot a day and you keep just a couple days worth, it's a parachute that you always have there so that you have a point in time you can go back to if something unfortunate happens. And it's very, very lightweight. But again, we'll get more into that here in a little bit. So once you've done that data protection piece, the next part of the wizard as you set up this is around performance. And you have just a couple features that you can apply here. One is caching. Normal caching is generally what people use. You do have the ability, though, to choose pinned. And we talked about this before, right, when we talked about utilizing cache size and I/O and stuff. But the concept here is that you can basically tag the data associated with that volume in the access-based eviction caching algorithm as a level 7, meaning it will stay hot and it will stay in the cache all the time. And the beauty of doing that is now you got 100% cache read rate for that particular data set. So if you had a small database, you needed super low latency on that. You don't want to spend, $50,000 on an all-flash array because it's just a kind of a small workload. You could pin that, and it would basically, you'd get all-flash type performance out of that particular database. Just keep in mind that when you pin, though, that 10 terabyte database, that's 10 terabytes of cache that no other applications can utilize. So you're basically stealing cache capacity, right, from the overall cache for your system. So if that's something you think you're going to do, oftentimes what people do is they will bump up the overall cache capacity, taking into account what they want to pin, so that they still have that 12% flash to disk ratio, which is the target for best performance for standard caching for the rest of the workload. Hopefully that makes sense. So you have the pinned option. The other performance option you have to apply at a volume level is you've got some QoS settings. You can basically put an IOPS or a throughput limit on at a performance level. So if you have a very, very chatty monitoring software, let's say you're running PRTG in your environment, and as an IT department, you use that to do, monitor all 6 quintillion devices across the world that you have. And so it's super chatty, it's got a ton of IO, but performance is really not a big deal for that application. And certainly you would never want PRTG to steal performance away from your production databases that you're for the user applications, right? So you could put an IOPS limitation on the volume that you're running your PRTG and other IT monitoring applications out of, so that you don't have to worry about them ever overrunning or causing a problem with the, within the shared storage of the stuff that's going to be more mission critical. So just a concept and a way of doing that. Utilization of this setting is varied, and many customers use it in lots of different ways. Just so you know, also you can also create a folder within the Nimble array. It's just a logical designation, and put volumes inside the folder and apply QoS settings to the folder. So if you have multiple volumes that you want the same QoS applied to, you don't have to go to every single volume and apply it. You could put them all, group them all into a folder and apply it at that level. I already talked through all the different settings. I guess you're going to see all of this in the lab, but when you actually create the volume and you go into the wizard, the volume itself, aside from the settings that you apply to it, like the iGroup and the volume collections and the QoS settings, you're basically just going to give the volume a name. You're going to tell it where it's going to be. If you had multiple pools in your group, you could choose which pool, or if you had folders, you could choose which folder. You're going to assign the performance policy. You're going to tell it how big it's going to be. You're going to apply your volume collection, so you can create a new one, or if you have an existing volume collection, under data protection, you go into the pull down, you choose it, you apply your iGroup, you can create a new one at that point, or if you have an existing iGroup, you can just go to the pull down and let you choose it. If you are doing iSCSI and you want to use CHAP authentication, I've only met a customer once that uses CHAP authentication, but if that's something that is mandated or you need for compliance in your environment, you can do CHAP authentication to this as well with iSCSI. And this is also where you would go in and you would do multi-initiator access if this was a volume that would be shared in some kind of clustering configuration. And then you just hit connect, create. So creating a volume is actually very straightforward. You just need to know what those things are going to be. And once you've got your initial volume collections and iGroup set up, it's super duper easy. If you do this provisioning utilizing the VMware plugin, it will automatically create the iGroups for you. Just so you know, and the plugin walks through basically this same wizard where you choose all these kind of same things. It looks a little bit different than this, but it's all the same information. All right, let's see here. We already talked through each one of these pieces. We already talked through data protection. Talked through sizing, performance, volume collections. Once it's created and you go under data storage, and in the volume section, it'll give you a list of all your volumes. They'll be named out. You can see what their utilization is. You can see what their average IO and throughput is. On these different tabs, you can look and see snapshotting under protection, dig into performance more and space utilization. If you want to edit a volume, simply click on the volume and it pulls up the wizard and you can edit that particular piece. You can also change, modify, snapshot a volume using these buttons here at the top. As you select a volume, you will get information up here about utilization and data reduction. Yeah, I mean, that's where all the visibility is. It's not really that exciting, honestly, but if you need to dig in and manage one, this is where you're going to do it.